Hello, I'm going to make a demo of the test assignment I have for creating Teams API project. In scope of the demo or scope of test assignment, I need to create simple web API for Teams management, where each team consists of several team members and can work on several projects. For now, it's no strict data model, and data model are going to be updated in future. We're not talking about performance, scalability, and security. Web API project or the demo assignment needs to be able to create, update, and delete single entities, as well as provide aggregated requests like team with a team member or team with a projects. Programming language should be C#. Data should be stored somewhere, and also need some documentation. That's basically the test assignment. For the demo project, I've created a ESP.NET Core Web API together with a Postman collection of all requests implemented at the Web API. Data is saved or stored on a Cosmos database in Azure. Web application started locally, connected to Cosmos in Azure, and Postman execute requests against localhost. Let's start the project. On the first page we can see Swagger documentation with a description of all API requests and ability to invoke. For example, let's try something to call from a Swagger, like let's get all teams. And for now we don't have any teams. The same here on Cosmos database. In a Teams DB, in the Teams collection, there are no documents. What I'm going to do right now is to perform several requests from a Postman, just to here, like API call for getting all teams. It's empty. Let's create one team. Team 1 will be okay. It's possible to, let's create another one team. After team has been created, we are getting created object from the backend. Now I can get one team. I can also update and delete team, but instead I will create some project. Right now it's empty. I will create one project by providing team ID and the project details. Project 1. And let's also create project 2. Together with several team members. Team members is empty right now. I will create, providing project ID. As an example of aggregated request, we can get a single team with all project and with all team members. Like that, we have team with an array of members and array of projects. Yep. Let's go to the Visual Studio. Here project consists of two, solution consists of two projects, web API and the core services or core objects. Starting from the API, I have three controllers. First one for project controller, another one for teams, and another one for members. Basically, each controller does similar things like get all entities, or get, in this case, get all projects. Another one request for getting projects for a team provided by team ID. Next one is for getting single project by the project ID. Request for creating, updating and deleting project. Oops, delete project. The single dependency is provided via dependency injection, and this is team service. Basically, this service aggregates all actions for members, projects and teams, just to make it simple. Also, at the web API level, I have a very simple security model where each request is signed with a subscription key. Subscription key, it's some GUID, allow me to understand who is executing requests, and the subscription key is saved into the Cosmos database. For example, here while creating, for example, a project, I don't provide anything, and the author or subscription key is a debug one. When my application is started in the debug mode, I am generating the test subscription key, which is placed into the entity inside the persistent data store. It's possible to verify here if we refresh all documents, and all documents are saved into single collection but with a different partition key. Here it's a base type, and each entity has a base type, and the base type is available base types is teams, project and members. If we take some team, here we can see that author is a subscription or debug or developer subscription key. Later in the demo, I will switch into production and demonstrate how it's not possible to execute without key in production mode, and how different production keys are saved with the different entities. So once again, here is a single collection, but each item has own base type, and base type is generated based on the entity you are saving into the collection, and by the base type entity property we have a partition here at the Cosmos database level. If we check domain model in the Visual Studio, right here, domain model consists of three entities like team, project with its own properties for a project, and member as well with unique properties for a member object. There is no strict connection, or there is no relation at the domain model level between project, team and member. The weak connection is done by the property, by the team ID. in the member by the team ID, and in the project by the team ID as well. Team is some kind of root or top level property for whole domain model, but once again without any relation and without just with a weak relation by the key ID. Each domain object inherited from a base model with a basic properties like when the entity being created, modified, who is author of the entity, which version of the entity. We know that data model will be updated in future, so I think it's smart to store the version of the API which has created an object together with an object in the data store. For example, here in the teams we can see that this is version number 1. Also, each domain entity has a base type which is generated by the type of the domain entity and then passed to the base type property into the item in order to have a partitioning. For example, here team base type is team, and on a project base type is project. Next two main classes in the whole project is here, and it's data store and document store. Document store is a low-level data access class with a connection to the Cosmos DB with a client, Cosmos DB client class for executing basic actions against documents in the Cosmos database. Here we have actions like get single item, where we're using read document from the client. We're also creating queries for getting document from a Cosmos database. Also, we are getting here we are creating document, inserting or updating document, and also deleting documents. So this is generic class for doing basic operations on the Cosmos database entity or object. Here in the interfaces we have our main business level interface with definition of all methods we allow to do like against our data store actions for domain entities like projects, teams, and members, and actions like update, create, delete, and query. Implementation of the team service. Here under the hood holds 3 document services for each base entity, and also implementation is just a simple CRUD operations using our document service. Here, for example, let's take a look at the project level. So this is getting all projects, getting projects by author, getting single project, delete and create and update project. All similar applications are implemented here for member and for team. The only one method which executes not a single collection but an aggregate against all collections. Here is implemented just a simple 3 requests for getting team, all projects of the team, and all members of the team. If we run this application once again, so here is a method for getting team details, where it asks for a team, whole members, and whole projects. Once again, it's 3 API requests to the Cosmos database, but just for demo purpose, I think it's enough. It's okay for now. What do we have here? Authorization. Okay, so right now I will try to start the project. So I will try to start the project in the release mode. Just a couple words about authorization. Here we are getting our subscription key from a headers collection. Key for a headers is subscription key. And in case if we are in debug mode, we just generate the debug or reuse the developer's one subscription key. But in production mode, we just require that subscription key being presented. I will switch to a release and start the project. You'll see Swagger once again. We don't wanna, I don't care about debugging in release mode. Okay, we have our Swagger. We have all actions. We have all data models. Now let's try to execute something. Here in Postman, if I try to get all teams, we'll see that subscription key is required. So since now each request executing needs to be executed with a subscription key. Here is just a dummy GUID generated by, like, say, for demo consumer. And if I execute my request once again, I can see that for this consumer we don't have any teams. Let's create one team with a subscription key. This is the same subscription key, and let's try to create something in a production mode, like real team 1. Here we have real team 1 with an author of the production key. Let's try to get list of all teams. Author is this one. Basically, the filtering is performed like that. Let's see in the teams. Let's, for example, get all. We are read subscription key from a headers. And validate is something what we have here. We just getting the value from a request headers. Then we pass this key to our data repository or to our the data service. Here, author key, used here while we ask or while we filter by the items collection. So once again, author here for a team, for a real team one is this one, and author for demo teams is our debug or development time key. What else? Let's try to get all projects for a team. We can see that key is required. Let's provide a key. Let's provide a key. So I will grab the value from headers, get all headers key, same value. It's important because we filter by that. Get all subscription key, execute. We don't have any projects. Let's create a project, but as well we need to provide a key. First key, subscription key, create subscription key. But we also need to get a team ID because production team ID has a different ID. So here create body team ID like that. Let's call it real project. Here we have it. And when we try to get all teams on with a production key together with team members and with projects, let's provide a key here, subscription key and subscription key value. Strange, we don't have a team member. Team ID. Team ID. This one, team ID. Create team ID. Now we do have. Team and project. That's it. Just a couple words about the versioning, because we know our data model and relation and it will be changed in the future. This is just an MVP and proof of concept. So here at the API level, we already embed a versioning. We already have versioning right here. When we start Swagger, when we start application together with Swagger, we can see the current version. This one. And also version is implemented here via ASP.NET Versioning API, where we define which API version is implemented in this controller. For example, let's say the Teams controller, we have two versions. like that. In the version 1 we have set of actions, but in version 2 we have only Teams controller. So with that it's possible to define which object created by which version in order to track or trace so let's verify that we've implemented everything for the demo. Simple web API, Teams management, extensible or modifiable or weak data model without relations, no performance, no scalability, just a simple security, CRUD operations, aggregated operation, implemented using C#, persistent data store, and documentation is provided via the Postman examples and Swagger web API. Source code for this test assignment is published on a GitHub Teams API project. Here is the source code for API, for code, for the original task and Postman collection. That's it. Thank you very much.